Imagine you're floating in the deepest dark you have ever known. No stars, no planets, no light at all. Just an endless, crushing blackness stretching in every direction for trillions of miles. Now imagine that the most powerful space telescope ever built, a $10 billion machine that can photograph galaxies born just 300 million years after the Big Bang, is pointed directly at this spot. And it sees absolutely nothing. This is the Oort Cloud, and the fact that we cannot see it may be the most terrifying thing in all of astronomy. You may have seen headlines recently. JWST discovers the Oort Cloud. James Webb Telescope proves giant planet hiding in our solar system. Scientists panicking over what Webb found. I get it. Those headlines are engineered to make you click. But here's the thing. They're not just wrong. They're hiding a story that is actually far more extraordinary than anything they're claiming. The Oort Cloud has not been discovered by James Webb. It cannot be discovered by James Webb. It is, by its very nature, completely and utterly invisible to any telescope we have ever built or may ever build. It is a mathematical ghost zone. But what is happening right now, as we speak, is something that should be blowing your mind every single day. And nobody is talking about it the right way, until today. To understand what's really going on, we need to go back to 1950. A Dutch astronomer named Jan Oort was staring at a problem that had bothered scientists for decades. Comets. Specifically, long-period comets, the kind that take thousands or even millions of years to complete one orbit around the Sun. Here's what was strange. These comets were arriving from every possible direction. Above the solar system, below it, from the side, from behind. It was completely random, like someone surrounding the solar system with a giant spherical cage and throwing snowballs inward from every point on that cage simultaneously. And Oort had a genius realization. If the comets are coming from everywhere, from a perfect sphere, then there must be a vast spherical reservoir of icy bodies out there, wrapped around our entire solar system like a cosmic cocoon. How far out? Try 100,000 times the distance from Earth to the Sun. For context, light from the Sun reaches Earth in about 8 minutes. Light from the outer edge of the Oort Cloud would take nearly 2 years. It sits almost halfway to the nearest star. It holds trillions of objects, perhaps up to 20 times the mass of Earth, locked in frozen silence. And yet, we cannot see a single one of them. Not one. They are too small, too dark, and too impossibly far away. Oort didn't discover the cloud with a telescope. He proved it existed with mathematics. And that is exactly why JWST, no matter how powerful, will never photograph it directly. But here's where things get interesting. Because JWST isn't trying to see the cloud, it's waiting at the border, watching for what falls out of it. Think of it this way. The Oort Cloud is like a vast library, stored in a warehouse with no lights and no windows. Billions of books stacked in perfect darkness. You can't see the library from outside, but every so often, a gravitational nudge, from a passing star or a ripple in the galaxy's own gravity, knocks a book off the shelf. That book falls inward, falling for tens of thousands of years, accelerating. And when it finally crosses into the inner solar system, the sun's heat wakes it up. It starts to glow. It sprouts a tail. And that is when James Webb can see it. Not the library, just the pages, flying toward us one by one. Now, let me introduce you to the most terrifying visitor currently approaching our solar system. Its official name is C/2014 UN-271. Scientists call it the Bernardinelli-Bernstein Comet, named after the two researchers who found it hiding in a decade of archival telescope data in 2021. Its nucleus, just the solid ice and rock core before it even starts growing a tail, is approximately 75 to 80 miles across. That is a mountain of ancient ice, wider than the island of Manhattan is long. If you placed it on the eastern seaboard, it would stretch from Manhattan all the way to Philadelphia. For comparison, the comet that scientists believe contributed to the extinction of the dinosaurs? Its impactor was estimated at roughly 6 miles wide. Bernardinelli-Bernstein is more than 10 times that diameter. Now, before anyone panics, it is not on a collision course with Earth. It will make its closest approach to the Sun somewhere around Saturn's orbit, then swing back out into the deep dark for another few million years. We are safe. But the scientific value of this object? Absolutely priceless. Here's what made astronomers nearly fall out of their chairs. Telescopes including ALMA, the Atacama Large Millimeter Array in Chile, detected Bernardinelli-Bernstein actively outgassing, boiling off material into space, at a distance equivalent to somewhere between the orbits of Uranus and Saturn. That should not be happening. Comets are supposed to activate much closer to the Sun. The warmth is what vaporizes the ice and creates that glowing coma and tail. But this object was already erupting with carbon monoxide, a highly volatile gas, while still billions of miles from any significant solar heat. What does that tell us? It means this object is almost unimaginably pristine. Its ice hasn't been baked off by previous close passes to the Sun. It's been sitting in the deep freeze of the Oort Cloud, essentially untouched since the birth of our solar system, 4.5 billion years ago. We are not looking at a comet. We are looking at a time capsule, a frozen record of the raw, violent, chaotic chemical soup from which Earth itself was assembled. The water, the carbon, the organic molecules that may have seeded life on our planet. They were delivered by objects exactly like this one, billions of years ago. And these Oort Cloud comets are chemically different from their cousins in the Kuiper Belt, objects like those orbiting near Pluto. Oort Cloud comets are older, more volatile, richer in primordial organics. They are a completely different class of time capsule, from a completely different era of solar system history. Now here is where the story takes a genuinely mind-bending turn. The standard model of the Oort Cloud says it formed when Jupiter and Saturn were young. These gas giants acted like gravitational catapults, hurling billions of smaller icy bodies outward at enormous speeds. Most escaped the solar system entirely, but some, just the right number at just the right speed, were thrown far enough to be captured in distant orbits. That became the Oort Cloud. Reasonable enough. Except when astronomers actually ran the numbers, the math didn't add up. The cloud is too large, too massive, and objects like Bernardinelli-Bernstein, this 80-mile behemoth, are far too big to have survived being flung by Jupiter without being shattered. That kind of gravitational violence should have torn them apart. So where did they come from? Where did all that extra mass come from? The answer, and this is one of the most stunning ideas in modern planetary science, is that our Sun didn't build the entire Oort Cloud by itself. 4.5 billion years ago, our Sun was not alone. It was born inside a dense stellar nursery, a crowded cluster of hundreds or thousands of sister stars, all packed close together, all still young and chaotic. Their gravity fields weren't separate. They overlapped, they interacted, they tangled. And in that crowded nursery, something extraordinary happened. Our Sun's gravity reached across the space between stars and stole comets from its neighbors. Objects that formed around other young stars were gravitationally captured by our Sun before the cluster dispersed and the stars drifted apart forever. We didn't just build our own Oort Cloud, we inherited material from alien solar systems, from stars that no longer have names, from planetary systems that may not even exist anymore. Let that settle for a moment. When we look at a long-period comet falling through our sky, we might not be looking at our own history. We might be looking at the history of another star, another world, a solar system that died billions of years before our own species existed. And we have proof that interstellar travel between solar systems is not just possible, it's routine. In 2017, astronomers detected Oumuamua, the first confirmed interstellar object ever observed passing through our solar system. It came from outside. It didn't come from anywhere in our solar system. And it left without slowing down, on a hyperbolic trajectory that no solar gravity-bound object could achieve. It was a visitor from another star. In 2019, Comet Borisov arrived, the first confirmed interstellar comet. Unlike Oumuamua, which was strange and cigar-shaped and deeply mysterious, Borisov looked reassuringly normal, a comet that appeared almost identical to comets from our own Oort Cloud. Which raises a haunting question. How do we know our own comets aren't interstellar as well? The current answer is, sometimes we don't. And the more we study it, the more porous the boundary between ours and theirs becomes. If interstellar objects are passing through our system right now in the modern era, imagine how many were captured and trapped when the sun was young, surrounded by sister stars, and the gravitational gates were wide open. The Oort Cloud may be as much theirs as it is ours. And now, you know the truth. James Webb is not looking at the Oort Cloud. It is reading messages from the Oort Cloud. One comet at a time. One frozen time capsule at a time. One ancient page of solar system history at a time. The Oort Cloud isn't a place we can visit, or photograph, or even truly comprehend in human terms. It is a library assembled over 4.5 billion years, filled not just with the biography of our solar system, but possibly with the biographies of other stars, other worlds, other systems of planets that burned bright and then went dark, before humanity existed to name them. Every comet that falls toward the sun is a page from that library. A page that will be burned away, evaporated by solar heat over thousands of years, unless we read it first. And right now, with James Webb analyzing their chemistry and the Rubin Observatory standing ready to find thousands more, we are finally, for the first time in human history, actually reading. The Oort Cloud is invisible. It is unreachable. It may hold the secrets of how we came to exist and evidence of other solar systems we will never visit. And the most amazing thing of all? It's sending us books.